Hi everyone. So myself Eurifist and welcome back to the channel. Today I'm going to show you what I'm learning in system design and how much progress I have made, uh, and what are the resources I am following, and also I will share the notes with you guys. So yeah, let me show you. So yeah, as you can see, this I have studied total three lectures till now. So I will go through each lecture one by one, and yeah, let's see how it goes. So in the first section, I started by reading about client server architecture, which is very basic. It is just like there is a client, there is a server, and client makes a call to the server and server response and the whole architecture of it, which is like we have studied so many times. Then I studied about the networking fundamentals, where I see there are two types of model: OSI model and TCP/IP model. I studied these models in depth in computer networks, so I did not go very deep this time because I will revise computer networks again, but I have a good memory of it. So I just kept this topic. I just read basic. And also I mentioned the important things uh, which respect to the system design course, which I am following to this. So you can read everything from here, like what is three-way handshaking. It's just like there are two client and server. Client makes a call of, okay, no, acknowledgement that he needs to establish a, okay, the client makes a request that it wants to establish a connection with the server, then server responds with the acknowledgement, and the what is the message he received, then he also, like, there are three ways handshaking. Oh, I don't know why I'm like slurring. So yeah, then I studied about what are the TCP UDP headers, which are like very important. Okay, so and there are some important terms like short polling, long polling, WebSockets, SSE, which is server sent event. Okay, so if you, I mean, I have attached a image by I think what's the name? Yeah, bytego.com. It is a very good website for the graphics. In a short polling, it's like, the client and server. The clients make a request. Did I get the data? No. Did I get the data? No. Did I get the data? No. Or I mean, he keeps knocking the door after, let's say, a very short span of time. Did I get the did we I get the information? Did I get any new updates, for asking for the new updates? But in long polling, it's what happened. I knock the door once and say, is there is any update? And I just wait for a timeout period. And whenever we get a update, the server responds automatically. So we don't have to keep knocking the door. It's just, you know, reduce the server load, which is, so long polling is better than short polling in this. Then we have a WebSocket, which means we have full duplex connection. Full duplex means the client also can send the data, and server also sends the data, which happens generally in, you see in messaging apps like WhatsApp. In WhatsApp, what happens once the connection is established between a user and other user, then there is like no keep asking or keep sending the HTTP request. It happens over one TCP header request, one HTTP request. I don't know, I'm mixing two things. So it just, reduce the overhead, because when you request a HTTP request, when you send a HTTP request, you send a header which have so many metadata, which becomes redundant when we send so many messages. So instead, we just send the message. This is the whole thing about WebSocket. Then we have server sent event, where we just establish a connection once. Then it is unidirectional. It happens mostly in streaming services. Like in streaming services, let's say you just send a request that I want to subscribe this channel or this service, and you just get the subscription of that, and then they start streaming on your device or whatever device you have or using. So you're not sending data continuously for the next frame. It keeps sending you that frame. That's the thing. Then I attached all of the thing which I said recently. Okay, send here. I mean, I when I was reading about it, I made a mistake in mixing two things. There is a WebSocket and there is a webhook. So yeah, I mean, don't mix that. Webhook is I don't have image here. So I mean, webhook is different and WebSocket is different. Webhook is something like you told the server or whatever the body is that whenever you get the update, bypass these services, send me to this URL. You just send the URL. Let's say you make a payment request to Stripe. Stripe is a payment gateway like PayPal. Okay, let's take the example of PayPal. So you requested a payment to a PayPal and send a URL that whenever you get the update about receiving the money or whatever the status of payment, just send that to this URL, which is the front end side of generally the client side of it. So you just bypass so many middle services. This reduces the server heads or something like that. Okay, you can always study about it. Then I studied about architectural patterns, which is monolith versus microservices. In monolith, what's the uh, mindset is just keep all of the services in single code base. Let's say I have a service of payment, buy, sell stocks, and so many services, which is, let's say, I want to add a cart, I want to offer for a refund, or just wanted to get a refund, or whatever it is. So I just maintain all of that in a single code base. Or what I can do is just uh, distinguish the services and let them operate separately, and just talk to them via API. So what happen is, let's say there is a microservice of buy, there is a microservice of sell. So I will talk to them via API calls. If I wanted to buy a stock, so I will send a API request to the stock to buy the microservices, and it will respond to me. By this, what happens is microservices, if you want to maintain or you want to, do whatever with the services, it's easy to maintain microservices. Let's say during the peak time of any startup or any businesses, let's say there is this upcoming Flipkart sale, so they know their payment gateway will have a very high traffic. So what they can do is just increase the computation of the resources of that particular microservices for that particular period of time, let's say 2 or 3 days. So they don't have to increase the computation of the whole code base, which might increase the computation for the add to cart, which is not much important at that period of time, but it is just wasting the resources. So yeah, by creating a different set of microservices, we can maintain the whole code base much better way. And yeah, I mean, uh, I have written all of the things here. Or let me check. Yeah, there is RPC, remote procedural call, which is you use another local machine just like yours by setting a protocol. There is a protocol, there is an image, something like that. It's GPRC, which is HTTP2 version. I mean, I mentioned all of the things which I found, which is relevant for this topic in the notes. And also, I referred this blog. I mean, you must read this. This is very good blog. I have read all of them, all of it, sorry. So yeah, it is a very cool blog by AWS. So yeah, I think that's all. That's all I wanted to share. And yeah, see you guys with a new update. This is the what system design part one looks like. Yeah, thanks a lot. Thanks a lot for watching. Bye.